Hello, I'm Johnny Ball, and I'd like to welcome you to Thomas Salter's world of electrics and electronics. If you have a Salter Electrics kit, this side of the tape is for you. Today, most of us take electricity for granted. When we switch on a light, we never stop to consider the miracle of electrical illumination, yet the very first electric light bulb only appeared just 100 years ago. On this side of the tape, I thought you might like to hear a little of the fascinating history of electricity itself, how the discoveries were made which enabled us to generate electricity and then harness and control it, and so make electricity man's most powerful and versatile servant. For instance, where did it all start? Well, some 4,000 million years ago, the Earth was a very different place from today. Thomas Salter, or the BBC, hadn't even been heard of. In fact, there was no life at all, and the atmosphere was a mixture of hydrogen, methane, carbon monoxide, and ammonia. Altogether, a very poisonous sort of soup, and in recent years, scientists have recreated this soup and the conditions of long ago in a laboratory. Then they applied strong electric charges and ultraviolet light and found they could form complex molecules, the sort of molecules that could have formed the basic building blocks for life. So it seems possible, even probable, that life began on Earth thanks to the natural electricity generated in electrical storms. Man didn't become aware of electricity until about 2,000 years ago. It was around that time that the Chinese found that some metal-bearing rocks were magnetic. When allowed to float or dangle on a string, these rocks would turn around until they came to rest, always pointing in a north-south direction. At about the same time in Greece, someone found that a substance called amber, when rubbed on clothing, would pick up bits of fluff or cause hair to stand on end. Much later, in the reign of good Queen Bess, a man called Gilbert performed electrical tricks using pieces of amber or magnets. Remembering that the Greek word for amber is electron, Gilbert called his tricks electrics. He was the first man to realize that the Earth, if it attracted magnets, had to be a magnet itself with its own magnetic field. Around 1720, a man called Stephen Gray performed many electrical experiments, including suspending a servant boy horizontally on silken ropes. By rubbing a smooth glass rod, Gray produced static electricity, which he applied to the boy's feet. Immediately, the lad's fingers tingled and his hair stood on end. A Frenchman called Nollet repeated the experiment, and then Nollet used a chain of monks over a mile long, all holding hands. And he applied a very large charge of electricity to the chain, and immediately all the monks, every single one of them, jumped into the air with a shock. They probably broke their vow of silence as well, but Nollet had proved that electricity could travel great distances almost instantaneously. However, no one understood the nature of electricity, and experiments continued as the years went by. About 1786, the Italian professor Galvani accidentally made frogs' legs twitch. The frog's legs were being prepared for his sick wife, to get her hopping about again, I suppose. Galvani mistakenly believed that the electricity had been generated in the frog's muscles. His friend, a man called Volta, realized that the truth was that the electricity had traveled through the frog's legs on its way from a knife blade made of one metal to the plate made of another metal. Volta did more experiments and then produced a pile of discs. First, a silver disc, then one of zinc, then some flannel soaked in a salt solution, then another silver disc and a zinc disc, more flannel, silver, zinc, and so on. When static electricity was applied to the pile, it was retained and could be made to flow later on. Volta had discovered the very first electric battery, and this basic method is still used today to isolate certain elements, and in electrolysis or metal coating processes. This use of Volta's pile was extended by Humphrey Davy, who lectured regularly at the Royal Institution in London. But one lad who would sit regularly in the audience was destined to be one of the most important innovators in the history of electricity. His name was Michael Faraday. Most young people, when they get hooked on a hobby, whether it's football or music or electronics, begin to have dreams of reaching the very top in their particular field. The story of Michael Faraday is living proof that from a simple hobby, anything is possible. Faraday worked as a bookbinder, but he was frankly bored with the job. Bookbinding was a bit of a bind. He began to visit the Royal Institution to listen to Davy's lectures, and found them so interesting that he remembered every single word he heard. So when he got home, he'd write it all down in a book. Eventually, he went to Davy to ask for a job, taking the written lectures with him as proof of his keenness. Davy was bowled over by the completely untrained lad, and by coincidence, the post of a laboratory assistant had become available. Michael Faraday was given the job at 25 shillings a week. Within 12 years, which is a very short time in a career, Faraday had risen to take the place of the ageing Humphrey Davy. In the following 40 years, Faraday's discoveries helped to revolutionize the world by making electricity man's most important source of power. Faraday dangled a metal rod in a dish of mercury, and when he passed an electric current through the rod and the mercury, he found that the rod swung round and round a bar magnet for as long as the electric current flowed. This was the world's very first electric motor. It took 10 years to produce his second breakthrough. He discovered the dynamo, in which a moving magnetic field caused an electric current to flow first this way, then the other. This alternating current was made to turn a shaft, so the dynamo could produce rotary driving force. Eventually it was realized that by putting a wheel on the rotating shaft and driving it round using water or steam power, the motor would work in reverse and produce electricity at the other end, which is just how all our electricity is produced to this day. Finally, Faraday discovered the transformer, where a flow of electricity in one coil of wire can cause a flow of electricity in another coil, even though the two coils aren't connected. It's only because of this device that our whole electrical grid system works. Electricity is produced in power stations, and the pressure or voltage of the electricity is built up by putting it through enormous transformers. At these very high voltages, the power is pushed through wires and carried great distances over land by electric pylons. But when it reaches towns or villages, the power is too great for the electricity to be used safely. So more transformers are used to step the pressure or voltage down again to the usable level of 240 volts, which is what we use in our homes. Towards the end of the last century, electricity had begun to play a very important part in modern civilization, but still, nobody knew what electricity actually was. Then William Crookes invented the cathode ray tube. You probably know the cathode ray tube was eventually developed to produce television and give me a job, but this was some 50 years before television. The ray in the cathode ray tube is invisible, but it makes a fluorescent coating at the end of the tube glow. It was found that the invisible ray could be deflected by a magnet, which meant that the ray had to be made of something, some particles of some kind. In 1897, these particles were given the name electrons. The study of electrons then led to atomic research and an understanding of the makeup of elements that form every single thing that exists in the whole universe. It also led to the science of electronics, which can and does perform all sorts of miracles. Electrons can be transmitted and received through the air, making wireless possible. They can cause things to vibrate, making microphones turn sounds into radio waves, and then turn radio waves into signals that can be heard through loudspeakers or earpieces. It was discovered that light was electromagnetic waves, and colours were determined by the length of the particular waves. Then, the discovery that some electromagnetic waves had very, very short wavelengths led to the development of the electron microscope, with which we can see things much too small to reflect light in the normal way. Perhaps most important has been the discovery of the transistor and semiconductors and the silicon chip. Silicon chips work by incredibly small pulses of electricity attracting much larger parcels of electrons from one place to another. And it is this precise control of electrons that has brought us to today's computer age. Today, electricity is man's most important tool. So you see that your electrics kit may be thought of and enjoyed as a toy, But if it's what you want, there's no knowing just where an interest in electricity could take you. Wherever that is. Good luck.